Hey everyone, and welcome back to vCloud Labs. I'm so glad to have you here. Today, we're jumping into a really powerful topic, something that's a total game changer for any service that needs to be online all the time for a global audience. We're talking about the active-active multi-region blueprint. We all talk about reliability, but let's really think about what's at stake here. What happens when we're not just talking about a minor inconvenience? What if a few minutes, just a few minutes, of downtime costs you millions in revenue? Or maybe even worse, it shatters the trust you've built with your users. That's exactly the high stakes problem that an active active architecture is designed to solve. All right, so here's how we're going to break it all down. First, we'll look at why a single region just doesn't cut it anymore. Then we'll get our heads around the active active mindset. After that, we'll dive into the actual architecture blueprint and tackle the really tricky part, the data challenge. We'll also cover what it's like to operate this thing at a global scale, and we'll wrap up by asking the big question, is it even worth it? Okay, let's kick things off at the very beginning. Why is putting all your eggs in one geographic basket, a single region, such a risky move these days? Well, it really comes down to the limits of local reliability. I mean, just think about the services you probably use every single day. You've got Netflix, right? They have to stream video to you wherever you are without buffering. Or Booking.com, juggling a crazy amount of reservations and searches at once. And Spotify, it needs to work flawlessly for everyone, everywhere. For companies like these, a single region isn't just a bottleneck, it's a ticking time bomb. It's a massive single point of failure. When they go down, it's not a small glitch, it's headline news. So we see the problem loud and clear. Now, let's get our thinking straight about the solution because this is super important. Active-active is not just a fancy term for a backup plan. No way. It's a fundamental shift in how you think about and design your entire system. So what are we actually talking about here? Simple, really. An active-active architecture is where you have multiple separate regions, think East Coast and West Coast or US and Europe, and they are all serving live traffic simultaneously. The real magic happens when one of those entire regions fails. The system doesn't just crash and burn, it just keeps going, seamlessly routing everyone over to the regions that are still healthy. And this is a really important distinction. Think about traditional disaster recovery, right? You have a cold or warm site just sitting there on standby. When disaster strikes, someone gets a 3 a.m. call to go flip the big red panic switch. It's a huge catastrophic event. But with active-active, it's completely different. Both regions are always live, traffic shifts are automatic, they're graceful. A whole region failing isn't a meltdown, it's just a controlled degradation. Big difference. All right, so we've covered the what and the why. Now it's time for the really fun part, the how. Let's actually start architecting this blueprint from the ground up, starting with the clusters and moving all the way up to traffic control. Okay, before we even lay a single brick, we need to burn this rule into our brains. This is the number one most critical rule for a stable multi-region setup. Do not stretch a single Kubernetes cluster across regions. I'm serious. Trying to do this is a recipe for disaster. You create these absolutely horrifying failure modes because of network lag and partitions. It's a nightmare, especially for the control plane. So what's the right way to do it? It's actually beautifully simple. One region gets one Kubernetes cluster. That's it. So region A has its own dedicated happy little cluster, and region B has its own completely separate cluster. This makes each region a truly independent and isolated failure domain. That right there is the foundation for everything we're building. Okay, so if we have all these independent clusters, how do we get users to the right one? Well, that's where the global traffic layer comes in. I want you to picture an incredibly smart traffic cop sitting way up in the cloud, looking down on all your regions. This layer uses things like geo-aware DNS and global load balancers to constantly check the health of each region. Is one getting slow? Are errors creeping up? It sees that and automatically starts steering traffic away from the trouble spot, all without any human intervention. Now, here's a pro tip. Honestly, this is probably the single biggest thing you can do to make your life easier. Make your applications stateless. What does that mean? It means your app doesn't need to remember anything about a user from one request to the next. If you can do that, your regions become completely interchangeable. A user could hit your app in the US for one click and then Europe for the next, and they would never know the difference. This is a massive shortcut to a successful active-active setup. Okay, we've talked about compute, we've talked about networking, now we've reached what is, without a doubt, the hardest part of this entire puzzle, the data. Let me be really clear here. Your beautiful, resilient, multi-region architecture will absolutely live or die based on how you handle your data. You have to make a very conscious choice about your, let's call it, consistency story. And really, you're always balancing three things: latency, consistency, and complexity. For example, you could do regional writes. This is super fast for the user because the data is written locally, but you have to accept that it might take a little while to show up in the other regions. That's called eventual consistency. Or you could try data partitioning, where you say, okay, all European user data lives in the Europe region, and all US data lives in the US region. That gives you strong consistency within that scope. And then there's the holy grail, global consistency. This means when you write data, it's confirmed everywhere before you tell the user it's done. It's the strongest guarantee, but man, it's complex and can be slow for the user. There's no magic bullet here. You have to pick the trade-off that's right for your application. So we've designed this incredible system, but what's it actually like to operate it day to day? Because let's be honest, building it is only half the battle. Running it safely, pushing out new code all the time, and actually knowing what's going on, that is a whole other level of challenge. First off, your deployments completely change. You have to start thinking of each region as its own blast radius. The safe way to do a rollout is to deploy to just one region first, and then you stop, you wait, you watch all your key metrics like a hawk. Are errors going up? Is latency getting worse? If everything looks solid, then you can roll forward to the next region. And you absolutely must have an automated way to stop the entire rollout if anything starts to look wrong. And to make those quick decisions, you need amazing observability. It's not enough to have just one view either. You really need two. You need your per region dashboards so you can zoom in and debug an issue that's only happening in, say, Asia. But you also need that global rolled up view to see the big picture. What's the total impact on all of our users? And you've got to be tracking the right things: availability and latency in each region, how your traffic is split, and of course, that all important metric, data replication lag. Whew, okay. We have covered a ton of ground. And as you can probably tell, this is not a weekend project. This is a serious engineering investment, which brings us to the final and maybe most important question of all. Is it actually worth it for you? So here's a quick checklist you can run through. You should really consider this when 1, downtime costs your business an insane amount of money. 2, your users are all over the world and they really care about speed. 3, you actually have the budget to pay for running duplicate infrastructure in multiple regions because it ain't cheap. And finally, and this is the big one, your data model can handle this consistency trade-offs we talked about. If you can't tick all those boxes, you know what? A simpler active passive setup might be a much smarter first step. This really gets to the heart of the matter. An active architecture isn't a band-aid you slap on after a terrible outage. It's a philosophy. It's a commitment you make right from the very beginning. This whole approach only succeeds when teams decide that failure isn't an option they'll react to, but something they'll design for upfront. And so that's the final question I want to leave you with. Take a hard, honest look at the systems you work on. Are they truly designed for failure, or are they just waiting for it? Hey, thank you so much for watching. If you found this explainer helpful and you want to dive deeper into more topics like this, please do me a favor and hit that subscribe button for the vCloud Labs channel. It really helps a lot. We'll see you in the next one.